Okay, in this video, we are going to be using more application problems with our matrix work. We're going to be able to add and subtract and multiply matrices when possible, and write a matrix equation equivalent to a system of equations. Now, when we have a matrix, it is important to know how many rows and how many columns the matrix has. That is called the order of the matrix. Rows are horizontal, columns are vertical. So if we have a matrix that looks like this, and we are looking at how many rows this has, because the order of the matrix is going to be rows by columns. So this one, if you're looking across going horizontal, there's 1, 2, 3, 4 rows, and columns are vertical. They go up and down, so there are 3 columns in this matrix. That is called the order of the matrix. So we are now going to use our matrix information. Let me get down to some problems. To solve some problems. All right, in this example, it says for the month of June, Maggie budgets $320 for food, $140 for clothes, and $80 for entertainment. It says to, first of all, write a 1 by 3 matrix, we're going to call it B, that represents the amount budgeted for each item. So 1 row, 3 columns. So 1 across, 3 up and down. So the amounts that we're going to put in here are the $320 for the food, the $140 for clothes, and $80 for entertainment. So now we are going to go to the next part of this. It says, after receiving a raise, Maggie increases the amount budgeted for each item in July by 5%. So what I am going to do is I want to see what matrix B, if I raise those numbers 5%, and I can actually do this in my calculator. I want to know what this matrix B is if I multiply it times 5%, which would be 0.05. So let's go to our calculator. And go to matrix. So we're going to follow the steps. We're going to go second, then matrix, which is the x to the -1 button, and we're going to create a new matrix. So go over to edit, and we're going to edit matrix A. So the first thing we need to know is tell it how many rows and how many columns. So this one has 3, oh, excuse me. So this one has 1 row and then 3 vertical, so 3 columns. So that's what I need to tell the order of this matrix. So 1, enter, 3, enter. So you should have the same number of blanks on your calculator to enter what we entered for that first matrix. So we're going to enter our numbers, 320, 140, and 80. Now I'm going to do second quit. to get to the home screen. Okay, now this is going to be kind of confusing because we're calling it B for budget, but we actually stored that in matrix A in the calculator. So I want to know what what I just stored in the calculator times 0.05. So second matrix, there's the one I just stored in the calculator, so enter that, then multiply it times 0.05, enter. So let's see what this does now. So it says to call this matrix R. So after she got her raise, she got to add 5% to this budget, which is what we just did in the calculator. So it tells me 16 is added to the first, 7 can be added to the next, and 4 can be added to the last. So now, the last part says to find what B plus R is and tell what those entries represent. So we want to add this first matrix to this next matrix. We can either do this by hand. When you're adding two matrices, you are just going to add the corresponding spots, like this first row, first column to that one. So if I add matrix B to matrix R, I add the 320 to the 16, which will give me 336. I'll add the 140 to the 7, which gives me 147. And then I'll add the 80 to the 4, which will give me 84. So what do these numbers represent? That is, remember, the first item was what she budgeted for food. Well, in June, she budgeted $320, but in July, she got that 5% raise, which means she got to add 16 to that $320, which means in July, she gets to budget $336 for food. Remember the second column was for the clothes. She budgeted in June $140. She got to add $7 because of her raise, which rose her July budget for clothes to $147. And then the last column here was for entertainment. In June, she got to budget $80. She got that 5% raise, which was $4. And then, so in July, she got to budget $84. So that's what this last matrices in the black represents. That represents what she got to budget in July because of the 5% raise from June. All right, in this next example, it says that Waterworks Incorporated manufactures 3 types of kayaks in its 2 plants. The table below lists the number of each style produced at each plant in April. So there's 2 plants, Madison plant and Greensburg plant. The next column shows what each of those plants produce of whitewater kayaks. Same thing for the next column, except ocean kayaks. And then the last column is each of those plants, how many crossover kayaks they produce. So it says to write a 2x3 matrix, 2x3 matrix A. So we're going to call this one matrix A, that represents the numbers in this table. So let's see, 150, 120, 100, 180, 90, and 130. So that was for April. The manufacturer increased production by 20% in May. So we're going to call this next one matrix M. I can find matrix M, so I can either go through and multiply all those by 0.2, or I could do that in my calculator. So second matrix, go over to edit. We're going to put in our matrix A, which is a 2 by 3 matrix. So change the order to 2 by 3. So now we have all of the spaces that we need. So we're going to do our entries. 320. Oh, whoops. That's not 320. 150 in the first entry. 120. 100. So there's my first row. The second row is 180, 90, and 130. So what do I want to know here? I'm coming up with this new matrix M that shows the increased production by 20%. So I want to add 20% to each, or see what 20% of each of those numbers in the first matrix are. So let's go, I want to multiply this matrix by 0.2 for 20%. So second quit. So I want this new matrix that I have stored in my calculator. So second matrix A, so that 2 by 3 is the 2 by 3 that's over on the whiteboard. So I want to enter that and then multiply that times 0.2 for 20% and enter that. So here's my new numbers going across the first row. 30, 24, 20, 36, 18, and 26. So that is going to be the numbers that in part B, that shows matrix M that represents the increased production figures. So that is how much it increased from April to May. So now I want to add those two together and see what this represents. So I can either, like I did in the last example, just go through and add the corresponding figures, or I can do this in my calculator. Because remember, I have in my matrix stored, so second matrix. Now remember, the one that I have in A is this one right here. I've already got that one stored in there. If I want to add this to this matrix, let's just store this matrix in matrix B in my calculator. So I'm going to go over to edit, down to matrix B, and I'm going to enter the increase of May's production, which again is a 2 by 3. Enter the entries from the matrix I have for M, which is 30, 24, 20, 36, 18, and 26. So there's this matrix. So if I want to, now I just want to add those two matrices together. So let's do that in our calculator. So I'm going to go to quit. So second, quit. Now I'm going to add the two stored matrices. So I need second matrix. So this one is going to be matrix A. That's what I have stored in there for matrix A right now. Now I want to add that to this matrix. So second matrix, that's the one that we have stored in our second matrix, matrix B in our calculator. So go down to B. So I'm adding these two matrices together. So let's see what matrix A plus matrix M gave us and figure out what those numbers represent. So A plus B gave me 180 across the first row, 144, 120. The second row is 216, 108, and 156. So let's see what these mean. So part C says, tell what the matrix A plus M and tell what it represents. So matrix A told the number of each produced style at each plant in April. Matrix M was increasing that by 20%. So we did that times 0.2 to get matrix M. And then when we added the two matrices together, this is talking about the number of kayaks that were produced at each plant in May. Okay, in this next example, it's saying that one slice of cheese pizza has 290 calories, 15 grams of protein, 9 grams of fat, and 39 grams of carbs. A half cup of gelatin gelatin dessert has 70 calories, 2 grams of protein, 0 grams of fat, and 17 grams of carbs. And then 1 cup of whole milk contains 150 calories, 8 grams of protein, 8 grams of fat, and 11 grams of carbs. So what we are going to do for part A, we are going to write 3 different 1x4 matrices. So 1x4 means 1 row with 4 columns. So we're going to call the first one P for pizza. So entering our values, 290 for calories, 15 grams of protein, 9 grams of fat, and 39 grams of carbs. The next one we're going to call G for gelatin. So the columns are all representing the same thing. The first column is our calories. The second column is our protein. The next column is the fat. And the last column is the carbs for each food. So the gelatin, we have 70 calories, 2 grams of protein, 0 grams of fat, and 17 carbs. And then 1 cup of whole milk has 150 calories, 8 grams of protein, 8 grams of fat, and 11 grams of carbs. So, part B says, find what 3P plus 2G plus 2M and tell what the entries represent. So, I am going to put each one of these matrices in my calculator. So, second matrix. Going over to edit because I want to edit a new matrices. So we're just going to kind of remind ourselves that this first one, the P, we're actually going to put in matrix A in our calculator. So I need to tell it the order, which is 1x4, and then enter those values. So 290, 15, 9, and 39. So there's the pizza. Then the next one, I want to enter the gelatin dessert. So I'm going to go to second, matrix, back over to edit. And we're going to put the gelatin in matrix B in our calculator. So edit matrix B. It's also 1 by 4. And then enter the numbers for the gelatin dessert. So 70, 2, 0, and 17. And then the last one was for the cup of whole milk. So we're going to put this in our calculator in matrix C. So second matrix, go over to edit, and we're going to go down to matrix C. We need to tell it also the order, which is 1 by 4. And then enter those values. So 150, 8, 8, and 11. So now we have entered all of this into our calculator. So now it says to find what is 3P plus 2G plus 2M. So remember how we represented this. The first one, the pizza, is in our first matrix, matrix A. The gelatin is in our matrix B, and the milk is in our matrix C. So let's recall that when we go back to our calculator. So I'm going to go back to my home screen. So second, quit. So in my calculator, remember pizza is in matrix A. So I'm going to go to second. Oh, hang on. Not second yet. So 3, because I'm going to do 3 times that. So 3. Then second matrix, I want to use that pizza matrix, which is in matrix A. So there's 3 times the pizza matrix plus 2, and then second matrix. Now I want the gelatin matrix, which was in matrix B in my calculator. And then plus 2, and then the milk matrix. So second matrix, and we put the milk matrix in matrix C. So 3 pizza, 2 gelatin dessert, 2 milk, enters. So let's see what that gives me. So 1,310, 65, 43, and 173. So what does this represent? That represents if you had eaten 3 pieces of pizza, you're going to have and 2 gelatin desserts and 2 cups of whole milk, you would have consumed, that first number is the number of calories. So you would have consumed 1,310 calories. The next number is the grams of protein. So you would have consumed 65 grams of protein. The next one is the number or the grams of fat. So 43 grams of fat. And the last column is the number of carbs. So you would have consumed 173 grams of carbs for eating these amounts of those food and drink items. Okay, this last example is talking about 2 of the items sold at Sweet Treats Bakery are gluten-free bagels and gluten-free donuts. The below lists the number of dozens of each product that are sold at the bakery's 3 stores in 1 week. So the Main Street store, and this number is in dozens, so it sells 25 dozen bagels and 40 dozen donuts. The Avon Road store sells 30 dozen bagels and 35 dozen donuts. And the Dalton Avenue store sells 20 dozen bagels and 15 dozen donuts. So the next thing says the bakery's profit on 1 dozen bagels is $5, and its profit on 1 dozen donuts is $6. So I'm going to work with the bagels first. So here is my bagels. They earn $5 on each of those dozens. So what I'm going to do in my calculator is enter that row that has 3 columns, and I'm going to enter it in matrix A. So I'm going to have 25, 30, and 20. So let's go to our calculator and edit a new matrix. So second matrix, over to edit. This time I have 1 row and just 3 columns. So let's enter these. So I've got 25, 30, and 20, and enter. So this is our bagels. So now I'm going to do the same thing for the donuts. I'm going to enter, so this is the bagels. And then the next matrix, which I'll put in the second one, is the donuts. So here I've got 40, 35, and 15. So I'm going to put that in the second matrix. So second matrix, go over to edit and down to B, and let's put in our donut numbers. So the order is 1 by 3, and those numbers are 40, 35, and 15. So when I want to solve what this is asking for, let's look at what this says. The bakery's profit on 1 dozen bagels is 5, and 1 dozen donuts is 6. So I want to know, it says use matrices to find the total profit on these items at each store for the given week. So I'm going to go to second and quit to go to my home screen. So if the bakeries make $5 for each dozen profit of bagels, I want to know what 5 times this first matrix is for the bagels. So I'm going to do 5, and then I want that matrix. So second matrix, that first, we stored the bagels in matrix A, so enter. So what is this telling me when I have 5 times matrix A? These numbers so in 1 week, the Main Street Bagel or Main Street Bakery makes, their profit is $125 from the bagels. Avon Roads is $150, and Dalton's is $100. That is their profit on the donuts. Now they make $6 for every dozen donuts. So I want to know what that number would be. So 6, and where did we put the donuts? We put the donuts here in matrix B. So I want to know 6 times second matrix down to B, enter, and enter. So here, this represents 240, 210, and 90. So this 6 times B is showing the profit on Main Street's donuts in 1 week. So 240, Avon Roads would be 210, and Dalton's would be 90. Now, if I wanted to actually show the total profit that they made from the whole thing, donuts and bagels, I could actually add those two together, or do 5, then second matrix A, and then add that to 6, second matrix B. So this is going to tell me what, if I added those two matrices together, that 365, 360, and 190 in the calculator is showing the total profit from bagels and donuts for each store. So Main Street's total profit from selling bagels and donuts is 365, Avon Roads is 360, and Dalton is 190.